Hello, this is the first in a series of recordings related to prescribed fire, the ecology and implementation of prescribed fire as a practice for land conservation in Wisconsin. And I welcome you to this, and I look forward to engaging with you both with these online lectures so that you can become familiar with these material, these data, at your leisure and on your own time. And then I look forward to meeting with you in person in the coming days in May for the level 1 training that we will do. This training is designed for the Wisconsin Natural Resources Conservation Service organization, and I'm really happy to be a part of it. So let me get two things. I'm going to share my screen and bring up my PowerPoint presentation. So what I'd like to do in terms of talking about the ecology of prescribed fire first is introduce myself. My name is Jeb Barzin. I'm the chair of the Wisconsin Prescribed Fire Council, and I've been both teaching prescribed burning and doing prescribed burning for the past 35 years. Most of my work has been here in Wisconsin, but I've also burned in Southeast Asia and in Russia. And in burning across these really broad landscapes, I've been fascinated by the things that are pretty similar, even though we're dealing with very different ecosystems, and then the places where things are really quite different. And that's as true with the landscapes that we burn in, but it's also true with the people with whom we burn. And so the number one lesson for everything that I'm going to probably repeat over and over is when you're dealing with prescribed fire, it's very difficult to say good and bad, but it is important to recognize where there are differences. And when I make a decision about whether it's the right thing for me to burn or not, it might differ from what is the right opportunity or conditions for you to burn. And that's that difference and understanding why there's a difference, which is key to being able to be effective and safe with implementing prescribed burn. And of course, those dual goals are always what is important for us. And that's also true whether you are working with private landowners for them to do burns on their own land, or whether you're doing burns yourself. And so that's kind of the overall theme for what we'll be doing today. In my 35-year career, I'm over 800 prescribed burns that have been done, and I'm still learning with every burn that I do. So either I'm a very slow learner, or the infinite variety of circumstances that occur with the prescribed burning allow for us always to be engaging and learning more as we go. So what we're going to do in these recorded lectures is basically I want to do two things. I want to present the details of prescribed fire, and that will be done through these Zoom recordings. And then I will also provide you with detailed lecture notes so that you have written materials that you can refer back to should you ever want to. And then finally, in May, we'll be meeting in the classroom, we'll be meeting in person, and as a class, we'll be taking a look at fire-adapted landscapes and understanding what they look like, and talking about scenarios of implementing prescribed burns so that you can begin to integrate some of the information that you're acquiring through these lectures. So that's what we will try to accomplish for level 1. And I'll get going with the first basics, which is the fire ecology. Why is it that we burn? To do that, I'll be talking about the history of change, fire-dependent ecosystems, fire as an ecological process, and then switching to how fire affects various components of any particular ecosystem, starting with plants, then looking at animals, and finally looking as we integrate fire but use it on the landscape as a conservation management tool. So I guess when we're talking about this, I come at it from a point of view of restoration. And so talking about defining, understanding ecosystem restoration is an important thing. My definition is ecosystem restoration is the effort to reestablish the biotic and the abiotic parts of a native ecosystem. And by that, I mean the living and the non-living parts of a native ecosystem that have been lost or reduced. And also, in this day and age, in addition to that restoring or bringing back the living and non-living parts of a native ecosystem, we have to reduce exotic and invasive species that have become dominant. And usually we call those as keystone species, meaning they affect the rest of the environment, the rest of the other species that they are living with. And so by saying they're dominant, essentially saying they're a keystone species. So we're reestablishing the species that should be there. We're reestablishing the things like hydrology and fire and soil characteristics that are important for those species to persist. We're also reducing the species that are invasive and typically exotic, which should not be there, and are changing the landscape because of their presence. And so those two things together are kind of the aspects of restoration. In a really nice, simple definition of ecosystem restoration, which I think is particularly elegant, it's combining the science, time, and partners. And the partners are an important part of this because essentially what we're talking about is most ecosystem problems are human caused. As such, they're going to require humans to mitigate, to solve, to revert conditions back to a more functional status. And so those partners and allowing that to occur over time is absolutely critical. And science, of course, plays an important role. I'm fascinated by change, and much of what we've talked about, and probably what most of you recognize, is that change has been very extensive in the upper Midwest. So in this photo point series from Prairie du Sac, Wisconsin, you can see a picture. This is the background of a picture of the Ellen Hardy dock at Prairie du Sac, Wisconsin in 1870, and you're looking southeast across the Wisconsin River from Prairie du Sac, Wisconsin, towards the Wollersheim Winery, which is indicated by the white arrow. So in 1870, you can see that pretty much the entire area that the winery was situated in was prairie, with some woods, as evidenced by the tree tops on the top of the lining. And I've actually looked at these trees, and they're not exactly on the top of the bluff, and we'll talk about that a little bit later. But by 1910, just 40 years later, you could see a lot of shrubbery encroaching in the valleys. You can see birch trees coming over the top and birch trees establishing themselves on Round Top, and cedars establishing themselves in areas where they could not be affected by grazing, so places where horses or cows could not get to. And then by 1993, so only 120 odd years after the 1870 picture, you can see this entire landscape is almost 100% forest. So in a very short period of time, we've gone from complete prairie to complete forest, and nobody did anything intentionally other than not burning. So these areas were grazed. If you look in this middle picture from 1910, you can see a fence line running up the spine of Round Top Bluff. So this was actively grazed. So people were still grazing these areas. But still trees were invading into this area because the grazing pressure was not so much as to completely eliminate the presence of trees. So by simply doing nothing, we converted a landscape from prairie to forest. And that change in just a little over 100 years is pretty spectacular. But let's unpack this a little bit and understand how much change has been occurring and over what time period it's been occurring. And for written history, we don't have a lot when we get before the mid 1800s, but we do have some tantalizing pieces of information. The first comes from 1673 when Father Marquette and Joliet were coming from Green Bay. They came up the Fox River, crossed into the Wisconsin River watershed at the Portage, and came down the Wisconsin River. And when they were coming down the Wisconsin River, they said, "We saw neither feathered game nor fish, but many deer and a large number of cattle." And of course, the cattle was almost assuredly bison in this area. Marquette and Joliet were very familiar with elk and other large mammals that occur in Europe. And they were not seeing those sorts of large animals. They were seeing animals that were much like cows that they were familiar with, but they were unfamiliar with this particular species. So it's almost certainly that when they were saying cattle, they were referring to bison and just didn't have a name for this new species. So on the Wisconsin River in the mid 1600s, bison were very abundant. 100 years later, Jonathan Carver took the same route, coming up the Fox River, crossing at the portage, and coming down the Wisconsin River. He was British, not French, because the British had just won the French Indian Wars, and so they were taking over this landscape and trying to see just what kind of landscape it was that they were now involved in, responsible for, however you want to talk about that. So Jonathan Carver was out there trying to say, what does our new land look like? And how does it benefit the British? Much of this land that Carver described was full of many tribes, but many tribes that have come from further east. So the Sauk tribe, the Winnebago, of course, is the Ho-Chunk, the Outagamie, they came, the Fox were here, and the Chippewa were recently ensconced in these northern areas, having pushed the Sioux further to the west and further to the south. But what's important is that there are more tribes and tribes that are not necessarily familiar with the plain states that are placed into this landscape, having been forced out of areas further east. And that may have had tremendous implications because Carver, in his trips, never mentioned cattle or never mentioned bison, never mentioned seeing those animals. And yet he spent quite a bit of time in this area. So from the mid 1600s to the mid 1700s, we're already seeing the likelihood of ecological change in that a major grazer that is occurring in this area quite likely has been eliminated. The other thing that's really important is what Carver said is he describes they landed at the village of the Saukees, which is Prairie du Sac, Wisconsin, and Sauk City. And then they went from the village of the Saukees to the highest area that they could see in the surrounding area, which is Blue Mounds, approximately 30 miles to the southwest of the Sauk Prairie area. And he looked back and he physically said, looking back to the village of the Saukees, and he says this quote, "For many miles, nothing was to be seen but lesser mountains, which appeared at a distance like haycocks, they being free from trees. Only a few groves of hickory and stunted oaks covered some valleys." So he's describing a prairie landscape with some trees in the mid 1600s from Blue Mounds looking back to the village of the Saukees. If we fast forward to circa 1840 to 1860, when government surveyors were surveying Wisconsin territory in order to create an organized network of land descriptions so that you could transfer lands from the U.S. government who had taken it from the Ho-Chunk and giving it to European settlers. And what they saw in those land survey records as it relates to vegetative descriptions is this yellow dot is where Carver was standing with his group on top of Blue Mounds looking back to the Red Dock, which is the village of the Saukees. So he was looking from here to here, and from the General Land Office survey records, we would say that Carver should have been looking through Oak Savannah all the way pretty much to Sauk Prairie. But that's not what Carver described. He described a prairie landscape which had small groups of or copses of oak and hickory growing in the valleys. So from the mid 1700s to the mid 1800s, we're already having a massive change or continuing to have a massive change, not just in the loss of bison, which had occurred earlier, but in a great beginning process of afforestation, where oak trees and hickories are invading into this landscape and creating a oak savanna kind of community that's occurring here. So much of the oak savanna in Wisconsin may not be as native as what we thought, in that it's a relatively recent phenomenon of the last 150 years or so. At this time, from the mid 1800s, or at least from the mid 1600s all the way to the mid 1800s, we also lost browsers like elk, predators like bear and wolves, and browsers like moose, of the wetland areas. All those species were lost in the 200 years from the mid 1600s to the mid 1800s. So there's other ecological changes that are occurring at the same time that we're seeing a transition from prairie ecosystems to oak savanna ecosystems. So again, then when you look at this change that's occurring from the mid 1800s to the mid 1900s, so the third century in this storyline, we're seeing further change from the areas that were still prairie to a complete forested scenario, not just oak savanna, but a complete forested area. And many of those forested areas are not what we would call fire adapted communities. So you're seeing lots of birch and lots of cedar that are in this landscape. So there's lots of cedar ringing this prairie opening here, and in other places in here where some of these open prairies were filled in with eastern red cedars. So a lot of change in 300 years, first losing grazers and browsers, then having afforestation beginning, and then finally, once those forests are created, them becoming wetter and wetter and having species switching from fire-adapted species to non-fire adapted species. All of that's occurring over a 300-year time period. What's equally interesting, so that where the winery is situated, we can see a conversion from prairie to forest. There are other places, such as on the top of Round Top, where prairie has persisted that whole time. So clearly, the rate of change that's occurring in these ecosystems is not the same rate, depending upon the landscape characteristics upon which that change is occurring. And so this allows both us to understand the degree of impact that is occurring, but also the degree to which we can still take restoration principles and employ them on that landscape. So we still have tools that are remaining in order to deal with restoration, even though we've had landscape scale changes to those same ecosystems. Those remnants, however, are not stable, and that if we look at aerial photos that have been taken starting in 1937, we can see a steady decline in the area combined of these remnants. So if you just look at the size of the remnant from 1937 until the present time, we're looking at a very gradual loss of about 2/10 of an acre of those areas as they get more and more forested. So this change, even in the areas that have survived the past 300 years of change, is still occurring. And so there is cost to not doing things. There's cost to losing. Cost is measured by losing some of the remaining parts that we might find as crucial to reestablishing healthy, diverse, relatively stable ecosystems when we're doing full restoration of both living and non-living processes. Just another example of that illustrates how different those rates can be. This is the south aspect of this bluff, which is being invaded by cedars and by birch, but on the north aspect of this bluff, that rate has occurred much more rapidly, even though historically, and if you look at the General Land Office survey records, this was still prairie on this side. Because it's wetter and colder, was easier for trees to invade in on the north aspect as well as the south. And you can see the evidence of that colder environment, wetter environment by the presence of snow, whereas the snow has pretty much been melted off on the southern and western exposures. Finally, from the mid 1950s until now, we have this kind of a third wave of change that is occurring, and that is you have these forested environments that used to be savanna or prairie, and now they're being really overcome by non-native exotic species. In this case, this is all buckthorn that's rubbing up in the armpits of these trees, which in and of themselves were fairly new, but from 100 years ago as opposed to from the last 50 years that the buckthorn has been coming in. But so these invasive species are kind of the new dominant, and that's why they're sort of not just restoring the living and non-living parts for ecosystem restoration, but you also have to deal with these invasive species that have become dominant, and buckthorn and garlic mustard, knapweed, quackgrass. Those are species that are example of these non-native exotic species. In some cases, a species might be native, like eastern red cedar, but the main part is that they're not adapted to they're not a part of a fire adapted ecosystem, or they're not at least dominant in that fire adapted ecosystem. So you have this biotic process, which are grazing and that sort of thing. You have an abiotic process, such as fire or hydrology, and you have the actual parts, the species that are within those systems that you're needing to manage. And all those three things need to be dealt with. Over the last few hundred years, that change has been extensive. So we've lost almost all of our tall grass prairie, almost all of our oak savannas because of these extensive changes. If we look on a landscape basis, the very broadest on a biome region, the Western Rocky Mountains create a big rain shadow. So it's driest to the west. This is semi-desert in this area. And then we have short grass prairie here. We have mixed grass prairie coming through the middle of the Dakotas and Nebraska and Kansas and Oklahoma. And then we have tall grass prairie in this island in the eastern part of the Midwest. And then finally, we have aspen parkland in the north, or oak savanna in the south, that basically are the final part of this gradient. Now, at this kind of scale, you can't see the heterogeneity that exists within a smaller area, but you get an idea of this overall trend that's based on a moisture gradient overall that's influencing the kinds of landscapes that we would expect to see, which is basically as it gets moisture, you can have trees become more dominant, as opposed to where there's less moisture, you have more grasses that are dominant. So you don't have as much invasion by eastern red cedar in the mixed grass prairies as you do in the oak savanna regions, and even less in the short grass prairie regions. And so again, there's different things, both the climatic regimes and moisture fall, as well as aspect and slope, that is influencing the rates at which these changes occur. But the changes are occurring extensively throughout these zones. If we look then at the pre-settlement vegetation, a map in Wisconsin that was developed by Robert Finley, we see a lot of heterogeneity, but most of these ecosystems are still largely fire dependent. So we have the oak savanna region in here, we have the yellow, which are prairies in here, we have the pineries here, and then the sands, which are jack pine, in this area. So we've got a lot of areas, and all of these are pretty well fire adapted ecosystems. And even some of our sugar maple might have probably had some fire occurring in those areas, such as we got in this area along the north of the lower Wisconsin River. Interestingly, though, what's important is usually when we've looked at pre-settlement vegetation, most of us have said this is what our target is for ecosystems as we want to return them. And the reason why I've gone into a fair amount of detail in terms of what changes have occurred for the last 300 years, not the last 100 years, is that we actually even know that there was a lot of change that occurred before the General Land Office survey records, which is what Finlay's pre-settlement vegetation is based on. A lot of changes occurred before this map was, or the data for this map was collected. So Finlay's map is correctly denoted as pre-settlement vegetation, but what's incorrect is saying that that is exactly the kinds of ecosystems that existed when things were functioning. They're a good hint to what ecosystems were functioning, but a lot of change due to loss of grazers and browsers, due to already afforestation that had already been occurring for almost 100 years before General Land Office survey records were even collected. It is not a blueprint in the engineering sense. It is a guideline as far as what ecosystems might have existed, but there's a lot more latitude than what we might expect. Latitude probably in species, as well as in fire frequency, as well as in the importance of browsers and what they do, and in terms of how much time that it takes to reestablish this. And those details are important as we try to talk with landowners as we move forward in trying to implement activities on the landscape that are largely based on this concept of restoration. The fire adapted communities or fire dependent communities that I'll focus on pretty much when I'm talking about this are prairies, oak savannas, oak woodlands, and wetlands. And of course, from prairie to oak woodland, what we're really talking about is not distinct ecosystems that have a very precise line that can be drawn between the borders of these two areas. But what we're talking about is a gradient in this case from no trees at all to a fair number of trees or a closed canopy. And then wetlands exist in that same sort of gradient, but the gradient that's very relevant for wetlands can be either hydrological or on shade. And we'll talk about that in a little bit. And that's really true with prairies too. There's a hydrological gradient in prairies, and that you can have dry prairies all the way through to wet prairies and so on. And so they can exist in that same gradient. So you have both moisture and shade that are integral parts of ecological gradients upon which your restoration activities are going to take place. So the savannas and oak openings, if you look historically, or at least at the time of pre-settlement, there was approximately 7 million acres in Wisconsin, which was about 1/5 of all of the state. And predominantly those oak savanna areas are south of the tension zone. And very few of those savanna ecosystems persist today, although a lot more probably persist than what we can actually measure through a mapping exercise, meaning that a lot of the components of those savannas still exist. The prairie landscapes in Wisconsin were fewer. There was about 2 million acres of prairie, but as I had said, that probably is an underestimate of the total number of prairies that used to exist in Wisconsin. But they've had the same sort of fate in that most of those areas are less than 1% of the original prairie remnants remain. The good news is that there are still a lot of scattered remnants of prairies. So even though they don't cover a lot of area, they still are important in their distribution, because that distribution enables a lot of species to persist in those few remnants. If we look at fire-dependent wetlands, you can have open areas like this emergent sedge meadow, and gradually incurring greater amounts of canopy cover as well as moisture. And what's interesting is most of the wetlands, but not all the wetlands, occur within the glaciated parts of Wisconsin. So these are all major wetlands that are occurring, and the terminal moraine is in this area. So the driftless area in here has much fewer wetlands that are existing in it, in part because the glacial moraines allowed for the conditions that enable wetlands to occur, whereas in the driftless area where there was a lot more erosion that was occurring and that sort of thing, and no glaciers to be moving soils around and changing topographies and making closed basins and things like that, did not occur in the driftless area. And so wetlands are more associated with river systems and floodplain areas and that sort of thing, as opposed to these more closed basins that occur in behind the terminal moraines. And because of where these wetlands are occurring, the good news and the bad news are basically the same thing. We've lost half of our wetlands, which is a lot of wetlands to be losing, but we've also retained half of our wetlands, which is a far better scenario than what we argued with oak savannas or with prairie. So climate, even though climate drives this main transition from the Rocky Mountains to the eastern seaboard, there's a lot of variability, such as topography and rainfall and fire that's occurring that shapes kind of where prairies and savannas exist. So basically, what you're seeing is a tension between climate-driven events and events driven by either other abiotic events such as fire or water, water not in terms of rainfall, but water in terms of groundwater and those sorts of things, or by living processes such as grazing and those sorts of issues, or people. And Native Americans had been managing these landscapes probably very intensively for millennia before Europeans ever came to this landscape, and likely were shaping where forested areas existed and so on. Returning fire to these fire adapted landscapes is therefore critical, and we do it through prescribed fire, meaning the intentional setting of fire for specific purposes that is done in a safe manner. And there's as many different ways of implementing prescribed fire as there are people who are going to lead a prescribed fire. Basically, it's a varied process, and that's probably its greatest strength as well as its greatest weakness. It will probably cause you great joy in your career, and it will probably also cause you a lot of gray hair in your career, because trying to communicate such a complicated thing is a challenge. And yet it's also the greatest tool that we have to implement and to learn. If we look at a fire needs assessment, meaning where currently in Wisconsin should our highest priorities be to get fire back on the landscape, we've in 2014, a team of people created this assessment, and the Central Sands, the Lower Wisconsin River, the Northeast Sands, and the Northwest Sands are very important, as are some of the pinery areas that are in northern Wisconsin. So if you take this fire needs assessment as accurate, it's meaning that a good chunk of the state needs fire every 3 to 5 years. And the bottom line is they're saying that in this map, there is a need for 1 million acres to be burned each year. 1 million acres. Right now, as our best estimate, we're burning about 75,000 acres per year. So if we are to meet the needs identified in the fire needs assessment, we have an order of magnitude increase that is necessary to achieve that. If we don't, by doing nothing, we will continue to lose a great deal of diversity and ecosystem function in our landscapes. And we'll talk about that a little bit more. But just in case 1 million acres seems farcical because it's so much more than what we are currently doing, there's two ways that you can look at this. First, you can look at what other states are doing. And basically, the darker the color, the more acreage is burned every year. And so Florida, Georgia, Kansas, and Oklahoma are all burning over 1 million acres a year. Now, you could argue that Kansas and Oklahoma burning 1 million acres a year might be pretty easy if your average burn unit is 1,000 or 2,000 acres, and they are big burn units in Kansas and Oklahoma. But Florida and Georgia have much more complicated fuel systems or much more complicated ecosystems, and they're still burning 1 million acres a year or more. And the difference is that they never lost their fire culture. They had it threatened, but they didn't really lose it in these regions, whereas in the Midwest, we've pretty much lost our fire culture for at least a century. So it is possible to burn 1 million acres a year. Oh, and the other thing I would add is that Florida is not exactly a sparsely populated landscape. There's lots of people that are in Florida and lots of complexity to that landscape. And so yet they're still able to burn fairly large areas on an overall or on a collective basis each of these years. And in Wisconsin, we can do more. Another way to look at it is if we look back 30 years, we have probably increased our capacity to burn tenfold. So a tenfold increase is possible. We've already done it, but we're talking about going a tenfold from where we are now. And I would say that 35 years ago, it would have been impossible to consider burning 75,000 acres a year. And so even though it doesn't sound very possible right now, and we don't know exactly how to get that done, doesn't mean that it's impossible to do. To be more specific in these examples, if you take the lower Wisconsin Riverway, it's approximately 95,000 acres in total area, and half of it, or almost half of it, is under state ownership. And yet, only 2,000 to 3,000 acres are burned per year on an estimated basis. The point here isn't that the DNR is doing a bad job. The point is that it's a challenge for all of us. It's a challenge for state organizations, for federal organizations, and for private landowners. So we all face this same challenge, and we all need to figure out ways that we can engage in trying to deal with these sorts of goals. So within these communities, you do have this variation in soil, slope, aspect, and shade, all of which basically are influencing moisture, a fundamental thing that's important for most living species. And so you, at one end, can have a very dry area, and another end have a very wet area. And you can draw the same sort of gradient again for shades, which create some of the great diversity that we have in the Midwest, and also creates the greater complexity and the greater opportunities that exist for restoration. So you can have dry or xeric prairies. Mesic prairies are the Goldilocks amount of moisture, not too dry, not too wet. And wet mesic is on the wetter side, so the soil tends to be more saturated. All those involve very different species that are occurring. And there is no way to draw a line between them necessarily that isn't at least arbitrary. You can, of course, draw the line, but your neighbor will draw the line differently than you will, basically, because it is somewhat arbitrary. But that is what creates our diversity. And so in this forested system, you can have the same sort of thing with xeric forests. If the xeric savanna is a barrens, you can have mesic or dry mesic, barrens or savannas, oak openings. They have lots of different names. And you can also have very wet areas in floodplain forests. So I want to switch gears a little bit here and talk about another factor, a non-living factor that's important in restoration. So we've talked about fire, and we've talked about water, and we've talked about canopy, all of which are important. But another factor from a completely different way of thinking about things is time. Time as it relates to change in these ecosystems and what's driving that change and how does it fundamentally work. So my first shot at this is to take you to two plantings that were done at the International Crane Foundation. And the line that you see here on the map is the border between this area, which was planted in the fall of 1980, and this area that was planted in the spring of 1981. Now, the thing that's really interesting is that you can see that there's a clear difference in the overall species that came from those plantings. It's not necessarily better or worse. This is big blue stem and Indian grass dominated, and this is prairie dropseed dominated, but they both have roughly the same amount of native species, even though they were planted with pretty much the same seed mixes. What I find interesting, however, and you could even ascribe these differences from an area that was planted in the fall versus an area that was planted in the spring. You can say, okay, fall planting versus spring planting has a dramatic effect on what kind of species that you're going to get established as a result of doing that planting. And all of that is interesting. All of that's important. And yet, to me, it's not the main story. The main story to me is that you're looking at something that happened in the fall of 1980 actually what you're looking at is things that were all the species that you're looking at that are in this picture germinated in the spring of 1981. But the picture was taken in 2011, 30 years after that germination occurred. And yet you still see a line that exists between these two plantings. Why? To me, the obvious answer is that the species that you're planting tend to be long-lived and slow to change. Prairie dropseed, these clumps take 12 to 15 years in order to form. So it takes 15 years, say, for this to become a mature plant. And it takes a long time for Indian grass and big blue stem to develop as well. Now, of course, it also might mean that they're slow in being able to move back and forth. And the point of this conversation isn't to talk about which of those two explanations are more accurate or more likely to occur. But the point is that change occurs, but slowly. And that concept is really important when you're talking with a neighbor and they spend a lot of money to do a planting and they're looking at the first growing season and saying, how come I don't see a prairie? And I imagine that each of you, if you haven't already experienced that, you will soon. Another way of looking at this is another planting, and based on the first photo point that I showed you, I tried to do an experiment. I worked at the International Crane Foundation for almost 30 years. And so I tried to do an experiment, and I tried to plant exactly the same seed mix. And I'm German and I can get really anal about doing all these details and that sort of thing. I tried to do exactly the same planting with the same soils, with the same proportion of seeds for each species, the same places that we collected the species from, the same way that we collected the species and cleaned the seeds. I just tried everything I could think of to do things the same. And then I tried to look at these species over time. So I'm just going to show you one planting, a planting that I did in the fall of 1990. And where the green arrow is a tree that should serve as a marker, that is to show you that this is the exact same field of view in each of the four pictures. But this is our 1990 planting at 4 growing seasons. So that's 91, 92, 93, 94. So in 1994, this prairie was dominated by Indian grass and big blue stem with some little blue stem, which is the ochre color. The Indian grass and the big blue stem is the tan color. You can see they're the dominant species after 4 growing seasons. And I thought, okay, we've got our prairie. We're done. No more change. It's going to look like this forevermore. By 9 growing seasons, what you see in this picture is a dominance of little blue stem, not big blue stem and Indian grass. Okay, well, that's interesting that the little blue stem was there and it just took longer for it to express itself relative to big blue stem and Indian grass. But okay, we're done. 19 growing seasons, see all these hummocks? These are the prairie drop seeds. And so it's only by 15 to 20 years that the prairie drop seed was able to be express itself as that full hummock and that full way that it affects the other species that are there. And the that time period of how long it takes, you can see even after 26 growing seasons, there's still changes that are occurring. And so there's sort of, two opposing things that are occurring. There's change that is occurring in every year, and that there isn't a quote stable prairie. It's always changing and dynamic, but there are long-lived species out there that are changing at very different rates. So it's sort of like the same picture that I showed you where you had that bluff, and on one side it was prairie, and on the other side it was birch forest, that the change can occur at different rates. And here you're seeing different rates of change within these prairies as they're developing over time. So, in this case, you're seeing 30 years of prairie growth, but that prairie dropseed was there the whole time. And I actually have collected data on it, and I can show you that the prairie dropseed was present from the very second growing season. We didn't sample in the first, but it was present all the way from the second growing season, pretty much at the same density throughout those whole 19 years. It just took a long time for it to develop its above ground vegetation to a point where you could see it in this sort of photo point. So time is a really relevant thing. And if you think about that definition of restoration that I gave you at the first, they included time in that definition. And for me, this is that quantification of why does time matter and what does it really mean? One other riff on time, so that you can I'm always fascinated with this and trying to get my mind around this. And so I'm kind of throwing my daughter under the bus. So when Annie, a week before Annie was born, I germinated seeds from compass plant that I intended to plant in honor of Annie's birth. And so this is Annie at 7 years old, and the compass plant for the first time was flowering at 7 years. So Annie and the compass plant are the exact same age. This is Annie when she was 18, and the compass plant is still there. And they're both doing great, I'm happy to say. Annie is now 32, and the compass plant is now 32, and it's still there. And so again, this is just a tangible evidence that the exact same individual that dies back every year at the surface is still alive and growing in the exact same place. So this plant, just like a tree, is 30 years old. We don't have any problems understanding a tree to be 100 years old or 200 years old. But the point being here is that these herbaceous species of vegetation can equally be as old. So said in another way, a compass plant growing on my bluff, if it was a wild native compass plant, could have watched Black Hawk retreat down the Wisconsin River and his band doing that retreat in 1832. And we might still have the same individual species that are occurring now. And so understanding that sense of time and what it means, because we have the individuals that are representing conditions that occurred a long time ago that are on that landscape. So there are a lot of echoes that can be occurring when we're thinking and doing and acting on restoration. And in part because that perenniality of these species is occurring below the ground, not above the ground, as it does in forest. In a forest, 2/3 of the biomass is above the ground. In a prairie, 2/3 of the biomass is below the ground. And that extensiveness below the ground is important. So these are feet. So this is 1 foot, 2, 3, 4, 5, 6, and so on. So they're saying that a lot of these species can be growing more than 2 meters down into the ground. And when you think about it, that deep, rich, black A horizon of typical prairie soils, a mollisol or things like that, involve that deep, rich A horizon. Well, that carbon got there because of these root systems that were putting it down. And that's a critical component when we start to think towards the end of this presentation on how do we take these ideas of restoration and implement them on privately owned lands in a way that makes the most sense ecologically, but also economically and culturally. So if you think about this, all this change that's been occurring, largely if you look at the threatened, endangered species or species of special concern that are declining and that we're worried about that exist in Wisconsin, almost all of them are in the precarious state that they are in because of afforestation, because we have rapidly converted our prairies and oak savannas and wetlands to a forested ecosystem that is fundamentally different than what these species are adapted to. That is true with birds like the red-headed woodpecker, that is true for invertebrates like the rusty patch bumblebee, and that is true for plants such as the purple milkweed. So that sets up the what are we going to do about it? So how does fire actually work as an ecological process.